We call this device an InBed, an ingestible microbioelectronic device.
To the best of our knowledge, it's the first time that living cells have been put inside an ingestible electronic device and then put inside an animal. And so it would be, one of the first times where cells are able to report their surroundings inside an animal and report that wirelessly outside in real time. So these are the 4 light detectors over here and over there that look at the luminescence that's coming from the cells.
Okay, so there are 2 major parts to this device. The first of which is living cells that can sense different biomolecules that might be in your gut. And in response to those molecules, when they sense them, they produce light.
So then the challenge is being able to see that light from within the gut. So the second part is actually this capsule where the cells sit on top of a set of detectors inside the capsule which can sense the light, and then the capsule transmits those light measurements outside the body.
The overall purpose of the device is to get a sort of idea of what molecules are existing in your gastrointestinal tract and how those might be related to health or disease. And we think that this could be an important tool that clinicians could use in the future to diagnose diseases of the gastrointestinal tract or of the liver, or to help manage these sort of chronic diseases that patients might have. As you can imagine, a colonoscopy is a rather invasive procedure, so we think that a device like this, which is ingestible, would be a little bit more comfortable for patients if it could provide the same sort of information to clinicians. In terms of safety, we started off by engineering cells which are naturally probiotics. So we use this strain of E. coli called Nissl 1917, which is sold over the counter in some countries as Mutaflor. So as a baseline, the cells shouldn't cause any harm to a human that would be ingesting them. On top of that, in the device, they're contained behind a semi-permeable membrane so that the cells cannot escape from the device. So, however, there are other groups that are working on other strategies in case the cells do escape, so that the cells would self-destruct if they leave the device.
We have a wireless antenna over here. We have a little microprocessor. That's this black piece here. There's some energy storage capacitors on the back there. So what we have right now is just a prototype, but security and privacy of the data is very important. Strategies like encrypting the data with strong encryption are ways in which we can help protect patients' data, and as we look towards scaling this to eventual clinical use, it's something that we would like to incorporate as part of the device.